Welcome everyone! Imagine being able to quickly switch between assets, shaders, lighting, or even cameras within the same scene, all with just a few clicks. Sounds incredible, doesn't it? Well, brace yourselves, because we're about to make this a reality, introducing LookDev in Katana. In this tutorial, we'll create a simple yet powerful Katana Arnold-based LookDev template that will revolutionize your workflow. This recipe brings scalability, efficiency, and reliability to your LookDev teams, transforming the way your artists work. Once you implement Katana into your pipeline, you won't ever look back. Approving assets becomes a breeze, and addressing nodes becomes faster and easier than ever before. Say goodbye to lengthy and tedious approval processes, and say hello to streamlined productivity. Let's jump right in. Templates are usually divided in many parts, separated with backdrops for clarity. Each of these parts executes its own necessary purpose. In the template we are building today, there will be 5 main steps. The first one will be importing assets and creating collections. The second one will be establishing lighting in the Gaffer 3 and setting up graph state variables. The third one will be an obvious and important step for LookDev, as we will be creating materials and assigning them to the asset. The fourth one will be look file baking and its magic. The fifth one will be building AOVs in Arnold and the render settings. And as a bonus feature, we will learn how to build a turntable project and turn it into a macro. The first step in creating any template is to insert nodes that will enable us to bring the assets we will be working with into the scene. For this captivating tutorial, my friend Emis, the robot, will be joining us. We will create 4 variations of shaders for Emis, as Emis is in fact an actor, and he must change his outfit frequently. We have several options when it comes to bringing our robotic protagonist into the scene, such as USD in, an Alembic in, an Importomatic, or a USD sublayer add, depending on the format we use to export our geos with. In our case, we choose a .abc format, so we'll choose an Alembic in. We can press tab and type the node we need. And as you can tell, it works. We can now see that Emis is present into the scene by clicking on the left box of the node we are viewing. Our robot is now displayed in the scene graph and the scene explorer, which is matching the path from the parameters. But Emis is low poly, and it would be great to subdivide it to get the proper final look. That's an easy task with the AttributeSet node, the UpScript node, or the ArnoldObjectSettings node. The AttributeSet node is a useful tool that allows us to override attributes in Katana. And as we like to say it at Foundry, in Katana, almost everything is an attribute. We can see that the type of each part of the geometry is set to polymesh, which means that it's low poly. We can change that type to subdimesh, which stands for subdivision surfaces. The first way we'll execute this function is by using an AttributeSet node. We want all our polymesh geometry to be changed to subdimesh. To do this, we must set our mode to cell and select Custom. We'll middle mouse click and drag the path of the asset and ask Katana to find all the types set to polymesh below this path with its expression. Then, we'll look for the attribute name type, which is string, and override the value to subdimesh. Now that the type in the Scene Explorer has changed to subdimesh. If you're unsure about the type of attributes you're dealing with, you can select the Scene Graph location and visit the Attributes tab. If you enjoy scripting and creating tools, you can push the envelope with an UpScript. The Cook interface provides a unified way to query and manipulate the scene graph. To create an UpScript in Katana, just create an UpScript node and define your cell statements. We will use the same custom statement we used for our attribute set. Upscripting uses Lua, so we will use the Lua module index. We know we will set a new attribute in the scene graph, so we will call interface.setAttribute, write the type as a string attribute, and set it to subdimesh. As long as execution mode is set to immediate, the code runs whenever you leave the script box. That is, whenever you click somewhere else in the interface. These tasks could also be completed using a renderer-specific node, like the ArnoldObjectSettings node in this instance. This allows us to easily access and control the asset's attributes for rendering. We will go under Geometry, select Smoothing, and under Subdivision Surfaces, set the subdivision type to Cat-Clark and set the iterations to 2. However, it's a good idea to understand other approaches in case you work with a different renderer in the future. We can start cleaning up our robot hierarchy the way we need, using different nodes as well. I will be using a Prune node, since we know these elements won't be needed in lighting. They can safely be removed from the scene. Middle mouse drag all the path you would like to remove of the scene directly over the add statements. We can make as many modifications at this stage, as we won't need them to be baked into the look file bake, which we will be seeing later in this video. After importing your assets, it can be useful to start creating collections. We can group related elements together by placing them under specific collections. Collections will not alter the assets hierarchy in the scene graph. Instead, they will provide a new path for each created collection, as you can see here. You can easily rename each collection. Additionally, you have the flexibility to add or move elements into those collections by dragging the desired scene path in the cell statements. If you wish to work even more intuitively and procedurally, as we have been doing it in this template, you can use expressions that call elements based on attributes or naming conventions in the custom statement. If you're creating many collections too, it could be a good idea to group all your collections under a node called GroupStack. In order to bring your nodes into the GroupStack, shift middle mouse drag all your collection create nodes to the Parameters tab. And there, we have a clean group for all our collections. Another way to have an easier control over those collections would be by setting up a macro. We will be building one for the turntable project later in this video. Now that we have dealt with all our assets organization, we can conclude this part by creating a little dot, which we will rename in the parameters in. This dot will be useful to separate what we need to bake from as an original pass to what we need to bake to as a default pass in the look file bake. I will color it black. To summarize this first video, we imported our little friend Emis into the scene, learned different ways to subdivide geometry, cleaned up the scene to prepare it for look file baking, and set up collections for later use. Well done, folks!